morning. This is Vika, your teaching assistant for data science. I would request you all to please confirm on chat if I'm audible to you. Thank you. Thank you so much. So we have a trainer online who will be taking today's session. As usual, please keep yourself on mute mode in order to avoid any background noise. Now that you're ending towards, now that you're ending the session almost, please start working on your project work. We keep coming up with the project submission classes, so to get the reminders, do come and join us and get an understanding on how and approach for project. Join those sessions as well. We will be giving the presenter access to our trainer now. Hi, good morning.
Morning to you. Am I audible?
Yeah, audible to me. So I'm
Thank
muting myself. Participants, the sessions, once they are scheduled, mailers are sent to all participants. So please do not worry about that. We keep coming up with these sessions almost every week. So the mail will be sent to when the schedule is ready. So Shubham, you start your session. I'm muting myself. Thank you.
Thank you. Nine. Yeah. Apple. Good morning to everybody. Conducting these project mentoring sessions. One we had last weekend as well. We will inform you, and then we'll have the next one. It happen like uh, uh, next week. So enough we have two these kind of sessions. Okay. Okay. Yeah, I think emails for that. Start today's session. A minute. Yeah, it was the last class. So let's start today's session. Done with uh, uh, association. In this class, we'll be learning classification. What is classification? So, classification, if you talk about, it is a supervised learning technique. Very good understanding of what we call as. We develop this understanding that supervised learning have one objective function which create from the past, past experience with some rules from past, and if we have some new events, and if we want to classify those new entrants, we can classify those new entrants into either of the into either of the group, knowing that those rules, those logics, that model, that objective function, that is something we have understood. Be taking you through one G of classification, and we will using the same methodology throughout. I'll tell you what we are going to do. Then I'll be picking up the techniques and will letting you know how to go about the things. Okay. So first of all, I'll tell you the generalized approach. Concepts, those all things will come up later on, but how we go out implementing it, that is something I want to show you. If you have the understanding of a validation data set, what into tuning and validation. Okay. So how we do it. So we need to solve any classification problem when we need to any kind of supervised learning technique. What we always go for data into two parts. I'll tell you why we do that. Yeah, training is used to build the model and it is used to validate our model. Yeah, uh, but that let's understand. I was explaining to you is here we have suppose customers, past data of customer. Few few here. One is suppose age, is suppose income. Okay. Third, have suppose address or location where these all customers belong to. You have a credit score. In India, it is called CIBIL score. Credit CIBIL score. About this customer, you know whether he defrauded or not, whether he committed a fraud or not. One represents committed the fraud, zero represents has not committed the fraud. So this all information about the past customers. Suppose a new customer is coming, let that customer as CN. You know about him, his propensity, probability, default or to commit the fraud or not. So that I need to find out. We could get the probability like 0.7. There is 70% probability that this CN might commit the fraud. So put this person into category 1. So you have two categories here, two classes here, 1 and 0. So I need to get to that result. Basic problem. So I have here 1000 records. We have here. What do we did into two parts? Data into two parts. One part is called data. Part is called test data. Validation data. Okay, so we divide our data into these two parts. How we divide that? We divide data randomly by random sampling. Which functions we use and how we do that will come later on. But we divide our data into two parts. Depending on ours, we have lesser data. So what we do, we keep more data into training because we just can't play with the uh, size a lot if we have small set of operations. As we have to build our model on training data. So 30 ratio is taken. So 70% of the data is given in training and 30% of the data is given in test. When we have sufficient amount of data and we have to divide the data in 70-30. Otherwise, we can also go for 90-10 because we have to test the information only, test data. So how we actually do that? Let me show you. So data into the two parts. There will be 700 observations in training and the observations test. So we have age, income, location, CIBIL, and fraud or not. So 1, 2, 3, 4, 5 variables we have. for customers. So if you see, you will have variables. So here, apart from customers, you have one, V2, 3, V4, 5, you're telling you whether or not. Let's let F. So you have all these variables here, and same thing will happen here as well. You will again have all these variables for customer. You have all these variables. You have fraud. You have one, V2, V3, V4. So a scenario. What you actually do, you the model on the data. Model, you will apply function. You will try to develop a relationship between these variables and the variable. How will develop the relationship? What all functions you will use? Which concepts you will go for? That will come. That will come later on. This is the methodology we follow throughout as learning techniques. Okay, so we will do a relationship between the independent variables and the variable. So this variable, the dependent variable, is called as response variable. In supervising techniques, in classification techniques, we call it response variable because here we have those categories. So we have the dichotomy, we have 0 and 1 only. Sometimes we have multiple categories. So this is what we have in a response variable, which is fraud. So last variable, which is the response variable, which is called fraud. So what we do, we develop the model. Suppose we have developed the model first and know somehow that this probability, because we're getting the probability here. Okay, so probability is equal to some function in terms of 1, V2, V3, V4, V5, V4. Okay, then we have gotten V2, V3, and V4. And we have probability specify or 0, into or 0. That is from here. Any questions so far? So we will get the probability value. Okay. More than 2 classes, no problem. More than 2 classes as well, you will get the probability values for class 1, for class 2, and for class 3. Scenario. We'll be doing decision trees. We might have multiple uh, things. Okay. So that can be done very easily. So really the bottom line is, with help of this this training data, we are finding out the rules. So we are trying to do. Found out this kind of rule. This value will be the propensity to 1. Suppose another uh, here don't know. But if I don't know as there will be some probability as well. Okay, this is something you can derive from the training. Okay. Praveen? So that can derive from your what you have this. Uh, you will get some values of errors. You will get some values which will help you to find out how good your model is. Okay, like you did in regression. So that is thing can easily be done. Still, you're looking at those error values and all, we always use the test data to test whether the model is good or not. Okay. What we'll do, we'll upload this in to check how we'll test. I'll tell you. So if you at data, our test data has all these variables: V, V2, V and V4, all variables, and as this variable fraud, we'll do the column here. Fraud value is the actual fraud value. This classification decision which we have on in reality, the actual. What we'll do, we'll use these all variables v1, v2, v3, and v4. We will give those variables as input to this formula, this function, this model. Find out the predicted value. So the predicted values here in the next column. How to predict values? By applying this formula, by applying this rule, by applying this model. If we have categories, 3 categories, 4 categories, we can always find out those probabilities, and according to those probabilities, we can classify actual values and predicted values. How we could not understand how we find out the predicted value, what actual value. Okay. Do you want me to repeat exactly? Actually, already have. This we already have data. So we have in the data because we have divided the data from the original data into 70-30 ratio. So actual values you already have. Now we need to find out the predicted values. Find out the predicted values. I'll tell you predicted values for the 300 people. Suppose you have one uh, C set 50. For 750, you know the value of V1. I mean, income, those all factors were there. So you already know values of V1, V2, V3, and V4. What you for this guy? You will put the values of V1, V2, V3, and V4 in this function. That you know with this new customer would be classified according to the formula, according to this model. That's your predicted value. So we want from and because the reality, because these are your past customers, the reality is 0. The premiums ought to be 1. Then you will see conflict. So these things will be discussed. We understood how we are gonna validate or how we are gonna test our model. anyone, any problem, because this is something people uh, take confusing. I don't know why, but but by considering the fact that people find it confusing, I'm taking it up at the. I did in our session as well, but in brief. Basically, implementing is something a different thing, but you should be able to understand here as well. We'll do these all techniques in a minute or two. You should be able to understand it at the macro level as well. What are doing here? So we have actual values already. We have gotten the predicted values. We are comparing how many of them are matching, how many of them are not matching. Basic thing. Okay, doing this. So everybody, I believe, understood what we doing in classification. After comparing how many of them got matched, how many of them could not get matched, we'll get out some percentage that this percentage of matching actual values. That okay. So do in classification. Okay. Now we do this. I do the very quickly. If you look at the model will also give you some parameters, so like deviance, null deviance, and all. It also help you to find out those error values, but still, we rely more on the verification. Is uh, the issue of overfitting and underfitting. What is overfitting and what is underfitting? Let's understand. Anybody has any idea? People who are in my project mentoring session, I discuss this thing as well to a very small extent. So I'll tell you what happens when you create your model, when you create your function, when you create the relationship. That relationship, that model, that should be very generic. We told you at the very outset, analytics is a scientific approach. Model which you are creating should be able to be applied on various other data sets because you will be using that model for customers. The objective is to predict new customer. So you have to apply that model multiple times, different customers on different prospects. Should be very generic. Once sometimes our model very good uh, for making our error, making our square value very good. What we tend to get overfitting issues. Our model gets overfitted on the data which we are using to create that model. Our model becomes the inherent property of that data only. It becomes so fit, it becomes uh, so very uh, data only that it would not be able to give sense for rest of the data. What happens? So a graph, this will help you understand this scenario. So you have the complexity. You are increasing the complexity of the model. axis, you have is that if you'll increase the complexity of the model, keep decreasing. Okay. Of the model, I mean to say you are trying to increase the value of R square, a number of variables by so you're doing different techniques, you're applying different uh, too much into the details, okay, add data only, and you are in the complexity. In terms of complexity, I'll tell you something to make it more understandable for you. Suppose you have outliers in your data, okay, and you're not removing the outliers, you are taking the outliers alongside with you. If outliers with you, what happens also become the part of your model are those observations which you might not see later on, which you not see in any other data. Those into this data set because some extreme cases. Okay, so we need to consider those because that only we take out outliers because we want to make a generic model. We don't want our model to be very complex. Example to make it understand better, you to so that you can understand it better. Supposing a decision tree, okay, suppose you are going for a tree which is uh, too deep. You have too many nodes. We in half an hour. The basic thing is you are increasing the complexity, and your error will keep decreasing. But this happen only for the training data set. Create the model. Once you will develop the relationship, once you have the objective function with you, you will apply that objective function, that model, that formula, that function, that relationship, all test data. What will happen initially as complexity will increase. Actually, there's some point after happens if complexity start increasing, and this validation data. So the overfitting, you are complicating your model. So overcomplicating your model. And how will you get to know whether your model is overcomplicated or not? First of all, for your experience, you try to develop a generic model, try to take out the outliers, you did not to include any which is very specific to that data only. Okay, do it at your end. And again, the far square, suppose you are taking 95%. That is might create the problem. So you look at these all issues, and after that, what you do, you apply the model on the validation data set. So only look at your own, the errors, the statistical parameters which are suggesting whether your model is good or not. You are not only looking at those things, also looking at your result of validation data set. That will keep telling you how good your model is. Any you people have understood how we actually do this? Let's do uh, one problem, and in that problem, I'll be discussing some techniques of R as well, R programming techniques as well. Understand how we actually go in classification, and then after that, I'll tell you the concept and I'll only tell you the formula. You can everything. So this is the basic scenario. We'll start off with our discussion with a neighbor classification. So data set with you, you must be in that data set and program as well with you that has been given to you as a part of project. The the name of the folder is project classification, and that is German credit. How many at date? That as well. Okay. You don't? I believe you should be having the code as well. How could not get the code? How do you have the code? Okay, with the codes. We'll be discussing it anyways. Document with you. I'm anyways discussing these all things in the class. Uh, Codes you have actually, you need to get access to that. Just here where you it. File groceries basically. Groceries, not groceries. German credit. I'm sorry. So start doing this. So first of all, let's file into our environment quickly. So in this file name called credit. a file of data environment. Let me here. We have default and checking status, duty, purpose, amount, saving, employee, installment. These all things we have. First of all, is sometime data. Seconds. Try to pick up the case which we have been discussing, whether the person defaulted or not. So that variable, that response variable you have, enter column A, column 0 and 1, whether the person defaulted or not. Status 1, history, purpose, amount. So you see here, you are getting these kind of values, A11, A12, A2. So this data is basically masked data. And what is masked data? What is the reason of masking? Yeah. So basically, let me tell you, this scenario you will face when you will be working in any consulting firm. Work for any consulting firm to uh, do an assignment in some company to analyze their data. Okay. So some credit company. Okay. External consultant. When they give you the data, they will definitely not give you the entire data. The way they will hide some information, they will mask the data because the data is very sensitive. See here, the data sensitive. You get to know many things if they will not hide the data. So they do, and they don't want to disclose the internal policies as well. There are many things they don't want to share with external people, but they want the analysis to be done. So A75 means something. You don't know what that means, but it has been masked as A25. Okay, so that is what happens. You have one 202. You don't know whether 201 is foreign or 202 is foreign. You don't know that. Okay. Yes, so it is basically the replica of the original data, but is masked by some other values. Okay. We'll be doing different things here to unmask the data, the categorical variables. Okay, so these all things we'll be doing in this case, and then we'll be in R as well. Now I have imported the file. Here that you need a library called class library. Class library will be used here. I have that library already installed. I believe you also installed it for the second class. You only need to call it from the library. Class. If you don't have to go to install and type class, type has various functions for classification. Done. Okay. Another nice done. Ankit is done. If you could not do, all are done very good. Uh, uh, a variable called default. I'm going to do. So first of all, I have different variables, different categorical variables, because in R we have not dealt with these variables. So when we'll be working on the projects, you might face problems. So I'll be dealing with categorical variables today to make you understand how we can change the values, how we can play around with these. I have a variable called default, very first variable, which is the response variable. So the variable, if I'll convert into factor, you will what have in that we have and one in that. Okay, so two levels, 0 and 1. So this is a variable which we'll be using as our categorical variable. Another history, history. So we have A30, A31, A32, A33, and 34. I'm telling you that A31 and A30 means good credit history. Okay, 32 and 33, there it is about poor credit history, and 34 means terrible credit history. Asking you data again for usage. How about that? Let it be hold. You basically had this kind of and you had these levels. Okay, so you send a factor, and that's what you did. How least value is good? Why can't in real times? How we determine? Again, this is not something we are determining. Mask these things. So I'll tell you the scenario. So the scenario is not clear here. Suppose you gave data for analysis to some external consultant. Okay, external consultant inside. Okay, is of good and poor. You put 2 and 33. What you have done, and back for our analysis, what you are doing, you are replacing the values. That's it. So I only want to tell you how you can sub the values. Okay, determine it. This is it is. Uh, good is swapped with A30 and A31. Later on, you swapping it just opposite. Okay. But to handle if we have many different numbers, many different numbers, you mean to say many different values. So dealing here with the categories. So when you create categories, let's try to understand the problem here. Whether you have small or large, that doesn't make much difference. So if you have many values, even what you can do, you can assign many values into different categories. So whenever you create categories, you just keep in that the categories should be uh, handled later on. So you always create categories which you can handle, we can manage. So categorization is never done where you create 1,000 categories. So categorization is done for a purpose. The purpose of categorization is to basically look at different buckets only, few only. So you don't categorize into categories. You never do that. Okay. The purpose of categorization is to look at only few things instead of looking at vast amount of vast vast variety of the data. Okay. Sense? Another if you have multiple values, if you have multiple values, those values can also be grappled. Those values can also be dealt very easily. Those things as well. Let's look at credit history. Look at the levels. We have changed it. Of A31, A32, A33, A34, and all. Now we have good, poor, terrible. So code quickly here. Variable as foreign. Have A201 and A202. I'm just telling you different ways to do this. This is one way. You can adopt this as well. There's another way. Function factor. You make the name of the variable. Mentioning levels 21 and 202. You are replacing these levels by values. So 201 will be replaced, will be swapped with foreign, and 2 will be replaced, will be swapped by German. At the variable now. Oh, yeah. Now have German values. Thank you so much. Just now. variable as rent. So this, if you look, one five one, 152, and 153. Okay, I'm interested only in 151 because 51 tells uh, that the person is living in the station. Other scenarios as well. If I'm interested only in this scenario and rest all scenarios, rest all categories, I want to put in some other category. So I want to create two categories here only. So that do here by this uh, again factor I'm using, and here we are using this logic. Crossing is equal to A51 or not. This logic we are using, and this logical output we are saving in the function called rent. So now two categories, true and false. True means the person living in rented accommodation. False means that person not living in rented accommodation. Just ways to handle this kind of data. Now, there are purposes of taking this credit. Data is masked. Data is this is earlier as well. So we have done this earlier as well. Here, the here as well. But only one thing I wanted to let you know here: we deal with too many redundant things. Like multiple times, how we can deal with that in a very concise way. So variables, these values of purpose, we have A40, A41, A42, A43. So for 40, we want to swap the value of A40 with new car. I want value of A41 with used car. But talk about 42, 40, 40, 45. These four values swapped with goods or repair. Now need to type here goods repair multiple times, like 4 times. Like here I repeated good word, but repetition for only 2 times. So I was good with that. I could do that thing, but I have to repeat it 4 times, and this is something which we might have to do multiple times. So instead of doing it in this way, what we can do, we can use repeat function. REP function repeats a particular text times as you want. So instead of typing here goods repair, goods repair, goods repair, goods repair 4 times, I will use repeat function REP good repair of 4. It will repeat this 4 times, and the values 40, 43, 44, and 45 we swapped with goods and repair. 46 you want you, 47 you want null value. You don't want any value. You don't have any value for that. You replace null values uh, with A47, suppose. Now you want them back. So if type here NA, so this we need to learn. When we type NA means is null value. Okay. Sequence. So we have the corresponding values here. For A50, we have to new car. For A41, used car. This way you go about it. That is hiding the level of purpose. So this is in correspondence with the O values. Okay. Okay. So we have created many variables. We have default as one variable, duration, amount, installment, age, history, purpose, foreign, rent. These all variables we have created. And if I want to keep this like this, we have multiple variables in the data. So what we can do, we can use function, concatenate function, combine function, and we can combine these variables with all the rows. So I have not mentioned here the number of rows. We'll take all the rows in the data. All the records of the data will be taken into consideration, but only these variables will take in the data. You have these variables now. I think we have just created. Called duration, amount, installment, age, history, purpose, foreign, and rent. These all have we have created. Yeah, how we go about. We only showed you how we can deal with the categorical variables. So unmasked data, yeah, Sudesh, you are right. Yeah, unmasked data, and that part I'll be coming into. Also, I'll be coming into. I have not yet showed you what we need to do. It's something I need to deal with. Uh, okay, so I want to show you how you go about the categorical variables, unmasking the data. Okay, sure. Everything, whatever I have written, start. That was a different story that came in because I have to deal with this data. I'll bring up only few variables to help explain concept. About k nearest neighbor classifier algorithm. That thing we are gonna learn. If I may proceed, if I'm with the coding part. So dealing with continuous variables, never dealt with numerical variable. That's the reason I took you through all this. In KDS classifier, what we do, if you look at this diagram on the right hand side, here I have some positive, here negative. Okay. So you already have some classification done. Okay. Anyway, something like this. I'll again compare with what we have done here. You have some customers data already with you. So there are some people who have been categorized as non-defaulters, and some people who have been categorized as defaulters. Now customer is coming here and you decide about the new customer whether that customer will default or not. This is new customer. Whether will fall into this or will fall into this. I think we need to decide. So I'll take back to the slide. This is an unknown record which is entered by this circle. Check. I need to date. I need to predict to size this the prediction for unknown record whether this will lie into plus or in minus. Which class this unknown record will belong to. This is a problem statement. Anyone understand the problem statement? Statement is to get classification done for the unknown record for the unknown customer. I have already put forth the case so that you can relate. So this is an unknown customer. You want to classify this customer either into default or non-default category. To classify, you look for different algorithms. So today we are going to discuss k-mean, k-nearest neighbor, KNN algorithm. We'll also be discussing decision trees. And logistic regression as well we'll be discussing. So use any of the techniques. In those techniques, the different, in the concept is different. So the logic, the concept, algorithm is as draw a circle around object. How you draw a circle, I'll come to that. But the basic is you draw a circle around this object, this new customer, and you check what the neighbors. So you draw a circle and then you check what all are the neighbors here. So just a moment. Here the neighbors, you plus neighbors here. Plus suppose you have minus as well. 2 negative. What after that? You go the voting. You go for checking. You have more plus here or more minus here in this circle. If in a circle you have more plus, then we'll put the unknown record into plus category. Otherwise, you put the unknown record into minus category. This thing. So basically what it shows here is
it is lying very close to us. So the close to this point, it will be kept in that class. This is the basic thing. To discuss about these all things, uh, you list points to perform classification. You need three parameters. You need stored record set. Stored record set means you data of old customers. If you don't have the data of the old customers, about whom you know whether they were the debtors or not, you won't be able to perform the k nearest neighbor classification algorithm. All you need is the stored record set. Second thing, you need distance metric. How you will get the distance metric. The distance metric will help to fetch uh, diameter, how you will draw the circle, and the value key, the number of nearest neighbor to retrieve. Okay, easy. So first step is to calculate the distance of unknown record with other training record. After looking at this distance, you will then go for identifying k nearest neighbors. And once identified k nearest neighbors, you will use class labels of the nearest neighbors to find the class label of an unknown record. So what is the class label of the nearest record? You will see and then go for the voting. Which label is appearing the most? So side the class of the unknown record. If the to class A, the class of the unknown record will again be class A. Not understand. So when you get into the implementation, it will be easy. You have some awesome functions to go for. You will use some functions and it will be done automatically for you. So you need to learn how to do that. What go in the screens. Anybody? Mean was entirely different. Clustering algorithm was unsupervised learning technique. Overlooked at unknown record as creators of all the records. What did K-mean cluster? Mind that we need to create 4 clusters. So randomly clubbed objects that points the records into 4 clusters, and then we found out cluster centroids. We wrote the distance of different data points, different records from that centroid, and we adjusted the centroids and all, and finally found out the. That is what we did over there. We are looking for the past data. Past has been classified, and past data we are class of the new. We are getting the class of any data. A customer, you can say here, the example which we are discussing. Truth. It seems like you have not visited the lecture. Different technique altogether. That is supervised learning technique. This is a supervised learning technique. A different issue to handle here in case supervised learning technique. We have past data. From the data, we need to decide, need to predict for any new for any new record. That's what we do in classification. So we have a different problem statement here. Over here, we just supervised learning technique. We did look at the past data. We didn't care about the past data. Whatever data we had, we only looked at the distances, and from those distances, we create the clusters. So I gave you this example as well. And we took you through a long discussion what is the difference between supervised learning and unsupervised learning, and I gave you some philosophical intuitive ideas as well. So I believe now it is clear. Nearest neighbor classifier. So if you one nearest neighbor, you drew the circle and you found only one nearest neighbor. It will be like this. If you two nearest neighbor situation will be like this. You have three nearest neighbor situation will be like this. So whenever you need to decide about the number of nearest neighbors, better go with the number that because that will help in the voting. If you decide that you want three to be considered, then will be better. You get more decisive results because three is an odd number. It simply means there will be two categories. There will be two instances, same class, so that the voting can use result. Once again, this computation will be from Euclidean distance methodology. Okay. Value of k. When choosing the value of k, you have to keep the following things in your mind. It is actually very important. In your mind is truths. If the value of k is very small, then it's sensitive to noise points. If it is too large, neighborhood may include points from other classes as well and might not get the result. Let's do it and try to understand it better. Basic algorithm, how it works. So illustration sake, let up instrument and age. not going through. Yeah, in a go. Considering only these three variables, let's quickly understand and implement it. So after that, we can use a scale function here as well, which we used in case of clustering. With you here because we could not do this thing over there. I'll show you here how we can use basic value basically. We can find out a mean. So we have variables here in x, 2, 3, 4. I show you what these three variables are. Head installment. You have taken these three variables, and what you are doing, you are subtracting the mean value from the individual objects, and they are dividing by the standard deviation to scale this function. Whenever we need to find distances, we always go for standardization. We always go for the normalization. We always go for the z statistic. Okay, that I've done here. If you look at this, I'm taking only the first three observations or of it. You can see here. What will the sample? Sample. As you will get confused. We need to find out the sample from 1,000 records. Out of 1,000, we want 900 records to be placed in data set. Rest records will place in data or validation data. So, a sample from 1 to 1,000 of them randomly to be picked. So function will pick 900 of these records randomly and those records in train. Now you will again. I'll show you how you will ensure these all are coming in this. Your data is x. Sorry, your data is x. What you're doing using this object as an input to this data. Upsetting this data now. So there you will be able to find out 900 records. You will be able to save those 900 records into an object called xstream. Then the remaining record you want, let's call it xnew. Okay, so n will have 900 records and xnew will have the remaining. So you have now two datasets ready. One dataset is your data, another dataset is your test data or validation data. If this data has the independent variables. This does not have the response variable. You need to see what your response variable is. That you need to save separately. So train and why new you need to find out. How it find out? Why? So file. From that only you will find out the response variable. That use default variable, and in default you will put train this value. Now you will do again. You will do again. Not everything with you. Somehow the window is not working. Went out. If you have understood. Look at the. Let me know if you have understood. So they're doing the partitioning of the data. Yes, we will function as well. That is also we have learned. Actually, taking you through with basic things, how data, how to look at different angles, how to deal with categorical. That's why I took it in this way. What is Manju? I have any code. What you are trying to say? I could not understand. You have pasted here some data sets, some, and different data sets, because here we are doing the random sampling. Put will match. So everybody will have different uh, uh, numbers. Okay, Nagesh is asking some question. This returns the line number of the sample, so we are using these lines to divide. Yeah, you got it right. Basically, it is uh, out the random numbers for the indices, indexes. It is looking for the indexes, row numbers, to make it very simple for you. So it is randomizing the row numbers, it to create the data. So in 1 to 1000, Okay, thousands you want to keep, want to 900 of those observations. You want to fetch by simple random sampling and observations into trained data. Yes. Okay, these are records. Yeah, 900, and we 900 simple random sampling. Great. Actually, everybody should have done. I highly appreciate Nagesh. This is something like, I'll tell you. Times I deal with these kind of students. I showed you what is VIF, how to find VIF, variance inflation factor. Okay, student actually create multiple regression models, and then he found out the tolerance, and from tolerance he found out the values of variance inflation factor, and he compared. So that thing he did in a time frame of like 2 minutes. He came up with different questions. So then the level of the class goes to a different orbit. Appreciate. So then I wanted you to understand you can use scale function as well this way, but this function is obviously easier. Will slap the that will increase efficiency. Okay. So let's move. You class library. You only need to use this formula KNN, and in formula KS3 will give train data and test data. Train is train data. X new is test data. Train test X new. Okay, and what classification variable? Basically, it is class label that is train. Let's okay, and now. So then create a default train thing which your so you are basically trying to find out how good is your model. So look at this value. Values quickly. Run these two lines. Okay, and look at this grid, this, and let me know what we are doing. It took a lot of time to understand this thing. I want your response here on we have understood. here. Yes, you are actually getting the point. And who what we have done here? Which Kiran, there must be because of one reason. Must have not executed the earlier commands. It might recognize what extra is. So there may be two reasons. Yes, one, you have not run this command. This run this line. You package already installed. And use y new. Okay. Now, can you get rid of your error? Amit, you install this package class and then you need to call it from the library. Please ask. Okay. You need one after another. Okay. Once we are done executing these two lines, we have done here. What we are doing here. Yes, right, Nagesh. It is C1. It is CL. Again paste. Uh, uh, I'm marking it. Yeah. So when it is CL, C1 is saying or it not recognize. Done. What we are doing. We took more time in understanding what happens behind the screen. So K function you use, K nearest neighbor. You gave X train, you train test, you give classification variable. Then you want three nearest neighbors to be taken. I've understood why we have taken three. Then you can see table. Table. I used this model first of all, nearest one. Like applied that model. Okay. And I this kind of grade. So what this is telling you, 0 and 1, 0 and 1. Axis again you have 0 and 1, and on the y axis again you have 0 and 1. Diagonal. That tell you the actual value and the predicted value from the model. Both were same. So 0 you found the same thing. If you look at 58 of times, value is also 0. That value is also 0. So 58 times you will 100. So you 100 run in your test data. Out of 100 records, 5 times you need matching. Okay. And times 1 matching. This is what you can see. So if you need to find out what percentage found correct, they need to look at the diagonal values. So if you are looking for the percentage, you can easily calculate that percentage. This function 100 into sum. New is equal to next one. 100. Total of 100 because you are dividing it by 100. So let's percentage. The rate here is 68%. Understand? So understood. Great. Manjunath wants me to repeat. Okay. So let me tell you. Is equal to 3. Derive it that way as well, and that way you find it more easier. Since I want to give you the formula so here I kept the things very simple. I intentionally divided the data into 900 and 100 Basically that you divide the data into 70-30 ratio. So diamonds are correct values, 58 and 10. 58 plus 10, 60. So out of 100, you have 38 records which are matching, values are matching with the predicted values. So 68. So it means you have 68 point match values. So accuracy is 68%. Are you getting? Yeah. Me three. We understood here. You have three values, so you are taking uh, three neighbors. Okay. So understood KNN. Have like 15 minutes, but I would give here only because we start with a new thing. We think will take time. So let's uh, take the break of uh, then 10 minutes. Let's come right after 10 minutes. And is it the logistic regression? And thing is entries.
Shubham, am I audible to you?
so much. Let's start the session. We lost around 7 minutes. That definitely do the compensation for. I would like to quickly tell you, you can use the diagonal function as well. Am I uh, we can use a diagonal function as well. Instead of using this logic, you can install DIAG, and before that you need to save this table. It DAB, a name you can give for that, and its number it will give you 68. And if you're looking for the error, so error will be, so the percentage which is matching, it will be the percentage which is not matching, which is also termed as misclassification error. So these terms will remain the same throughout all techniques. Whatever techniques we are learning in supervised learning, so these terms will remain the same. So the terminology we use is misclassification error. So 32%. So there are 38% which are 32% which are not matching. So 2% is the error. Okay, and is your misclassification error. It thing I have not explained in the class, but you can use plot. This is the name of the function, plot, and use that for different kind of plottings and some other functions. Those are mentioned in that PDF if you look at it. So go for that. We scarcity of time. We are more focused towards these techniques. We're spending more times on these techniques. Because of that, we could not do that. Okay. So let's now talk about another classification technique we have learned. Another classification technique is you will find those all things very easy. We come to know that error rate is high. Good question. And how we can revisit our model and correct it. Or you can play around with many things. With this 3, you change the value of 3, okay, to 7. That's true. Other than that, if you're getting of classification error, then you can add some other technique of classification. A few techniques work on some typical type of data. Few techniques don't work on that data. You have this wizard in other tools, like if you'll use StatSoft, it will suggest you the kind of methodology, the kind of technique you should go for the your hand. You have to do it manually by going for different iterations. So Boolean trees will also work in the same way, the way K worked. Everything remains the same. You have to divide the data into 2 parts, train and test. Okay, and train data you will apply the model model, you will check on the test data, and the same thing. Can be the same. Okay, but decision tree will work on some data in a very good way. On some data, it will not work in a very good way. But you have to check. And again, the second thing, decision tree will produce a different kind of output, which might be of great use for business objective. I'll show you what is the objective and what is the output of the this algorithm. Then you're able to understand and you will be able to compare the models. We will be able to discuss about different iterations. So let me quickly complete decision trees as well, and then we can get into that discussion. Okay. Take up this example. I'll not use the example. You have customer data. You have different customers here: C1, C2, C3, C4. Their values located. And variable, which is the response variable, come fraud or not. You have with you. And objective is again for any new customer you want to predict. That is the objective, and now you want to build the model. The data into two parts: generation data, train data, and test. You can call it test as well, as we have discussed. Trees actually give a very elaborated picture. An algorithm will not give you. So elaborated picture, you will be able to draw some more conclusions as well. So the information actually it fetches for you something like this. Difference, and out of variables it will pick up that variable which is affecting the response variable the most. Suppose it has picked up age. Here, a critical value of age. So it takes the critical value of age as 26. So for more than 26, it will produce different. Suppose income comes into the picture. It's less than 26, and income is less than 200 US dollars. Income. The person has sent branches in the same fashion, different branches. So you will be able to get to these critical values as well. Able to analyze the problem in a more granular way using decision trees. People prefer going for decision trees because of this reason. Trade-offs. So if business is demanding this level of analysis, you can go for decision trees then. Tree is nothing but this present in the form of a tree. You can get the rules only. You can get so these functions, these objective functions, this model. This is again a rule, but those are in the form of a tree, and you see different variables at different nodes. Decision tree. Let's create a decision tree. Let's do something so that understand it better. You need a package called rpart. Art is the package you need to install. Art. We have one data set, and we were running other techniques as well. I will be discussing some coding nuances so that you feel comfortable while attempting those projects. So, dot and import this file into R. Let me import the file. So I have the same thing. Add this NSP into. So let's look at this file. variables here. So I took this. If you'll see, you have three categories. For this is of patients, different and the fields are given here. Fields are actually related to medical science, so I'm not comfortable with that. But you need not to know much as well. I could fetch this data only here for you. So you have three categories here: 1, 2, and 3, and some it will pick up a few independent variables to make it easier for you. And if it works, then you will understand how you can apply on the rest of the data set, and you can apply on the data set which we just discussed as well. Defaulted, the red color data, you can apply as well. Okay, so this is the basic thing. Let me factor variable NF, which will be discussing. Let's see here 1, 2, and 3 here. For the data partitioning, the data in a way. Yeah, I'll paste everything. Pasting here the core data partitioning. So I code here so that I can make things faster. We can run our study. Let me call these codes in a go. Yeah. So see, so I'm get name partitioning. So this code, and let's discuss something after you have looked at the code. Lines are there. So you throwing things structure in a very structured way so that you can grab things better. So in of the P problem, I showed you how you can data of indices and is a way using any kind of thing that actually generates random numbers. What happens in the previous case? So I'll take through the previous case which we discussed. Yes, this one. And they look at this. What is doing basically? Converted it, turned it your way to create a sample to the partition. But what it is doing? This function actually 900 random numbers. It is 900 random numbers in 1 to 1000. This thing. Yeah. So basically, see what we are here. Again, using sample, we have to create two samples here. We give here again the number points we have. So number of records, n row will give you the number of records, what records we have in the data. We are going to replace here because we want to call sampling using replacement and with replacement. How many of you understand without replacement and with replacement? This was a very basic concept which we learned when we were learning probability in 11th standard, I believe. With and without replacement. Problem. So with replacement, without replacement is something. Suppose you are fetching two from a of well-shuffled cards. You picked two, those two. Am I well? Okay, thank you. Picking those two, your probability 50. So 2 divided by 52. Yeah, Nagesh. And exactly the same problem we used to solve. With a ball in the basket again and pull it. Okay. We can go for true or we can go for false as well. But we're actually creating two partitions, one for the training and one partition for the test data, for the patient data. Trainer we are keeping 80% of the numbers, and in test data we are keeping 20% of the numbers. That is what we are doing. But we are doing this. Before that, we have written here set dot seed. We have written 1, 2, 3, 4. Anybody can hear what is this? So relation can be done using sample function. You know what it is? So keeping so whenever we are randomized result is saved. I mean, and you can function once. It creates samples. It put different records in training and test data. Again, same thing again, and it will happen again. And so all of us will have different kind of data sets. The same function, but the validated test data sets will have different. The number is the same, but will print. So what fall in validation for me, it fall in test for one of you. Okay, so we'll create samples every time. Working creating a model, and that model is creating a data set, new set every time. Do you convenient for you? It actually start creating problems instead of helping you. So organization is okay, but once it is done, I want to deal with the same data set time again. Okay, so that is I want to say. So once you set the seed in 1, 2, 3, 4, you can have any number in that. You can any number in that. 10 here, any random number. Okay, have here 999444456, any number you want to, you can here, but do it at least once. So when the sample is created, it will not change. The randomization will happen once, and you use the data again. Other will keep changing. So then, but a set up of unique count this date in seed. That's what you are doing. You can have, this is any number. You're pinning down your data into this number. Okay. Now you screen and your validation data. So once Nagesh, once you will set the seed to 11 or any number for that matter, you will get same result. Time, but set the seed. This will keep actually you ran a pasted codes. So you would have run this command pd function you need to run. These formulae, I believe you used earlier formulae. quickly run this function r part. R the function, SPF is the variable, and we are taking LB in FM, and we are running it on train data set. You need to uh, r part dot plot. This package also you need to use r part dot plot. Now let's it. How done? Okay. This package r part. Do you see this package as well? R part dot plot. Just for that. It is a dependent package. It is under the dependencies. If you don't have this, then only you install it. Okay. To install it, r part.plot, you can go to install and type here dot the option coming. Okay. Packages and install it this way. Praveen, did you run the codes before that? have not run this code dot factor data NSP. Use code. Okay. Are you free? This I told you can two packages on install and use one and it. I start. Okay. So you had that, but let's focus on this output. Try to understand this output. That is important. Uh, happening here. Try to relate it with some other business as well. Picked up different variables. So you have different nodes here. So you have for AC, you have one node for LB, node for FM, you have here. Again, this node is for LB, then for FM, then for AC. From here, you are getting two nodes. So, understand what this is all about, and then we will read it with some sales and marketing data because you people are more comfortable with that kind of data. Just very arbitrary uh, extra, which is actually important in many cases. Here, if you see, we're looking for categorization. We will for the rules that data is uh, uh, what the data is speaking. So if I will look at AC, it created a point at the value of 0.0017. That we had percent of the data, and out of 100%, we had this kind of categorization. We had 0.78 in first category, 4 in second category, and 0.08 in the third category. This is the way data was divided into 3 categories. Anybody question? This criteria, this is the actual figure. This is the situation we have in our data set. No, random numbers. If you look at the data set, in that you'll have 78% of the data in category 1, 14% of the data in category 2, and 8% of the data in 3. Only. Okay, something is your categorization. So original data, if you look at, around 60% of the data falls under category 1, around 21% of data falls under category 2, and around 19% of data falls under category 3. Okay. If you look at here, we have taken, Nagesh, you are right. Here we taken set. In training data set, 80% of the data. So this is 100% of the data. We actually found 80% of the data, and in that 80% of the data, we again can create this kind of pivot table, and we find out that there are 78% of the records which fall under category 1. There are 14% of the records which are falling under category 2, 8% of the records which are falling in category 3. Are you me? Not doing anything, it is only showing you what your data is speaking out. The examples, one of the I did just after this very quickly. If you will look at these numbers, categorize the number. If 70% of the observations lying in 1, 70%, then basically you will put data into category 1, and that's why you have it in this color. Colors here, 1, 2, and 3. So you're getting it in 1 because category is predominantly got it. Then we are going forward. Then with this patch part algorithm in this package, we don't need to get into too many algorithms because for decision trees as well, it's only the package we use. There's another package which I also use that is called Party. You cannot package. So this is the last class, and after this, we're in the exploration phase. So you can check that package as well. Party is the name of the package, and you can use that package as well. Different algorithms are there. To the algorithm of our part, it is dividing the into two parts. Base condition. If AC is more than 0.0017, if more than 0.0017, then I'll go for yes. I mean on the left hand side. Otherwise, I'll go to the right hand side. If the AC value is more than 0.001, I'll go for sorry. If it is not more than 0.0017, I'll go for no. Now here we have other three. But if the value is more than 0.0017, I'll go for yes on the left hand side. Here we don't have any other tree. The tree is terminating here. So this node is called terminating node. So here, if AC is more than 0.0017, you are getting a very node, very explicit information. So you are getting one rule here. The rule is whenever you see in your data the value of AC more than 0.0017, you 97 values lying in category 1. Only 1 values is lying in, sorry, only 1% values in category 2 and 1% lying in category 3. And 48% of your data. Dividing the data according to this rule, AC more than 0.0017, you are dividing your whole data into two parts. One will be 52%, the second part will be 48%. If you look at the 48% of the data, the part which contains 48%, in that part, 97% of the records belong to category 1. So if I have any other new record, to classify new record, I don't know about its category, but I look at the AC value. If I find the AC value to be more than 0.0017, I make a statement that there are 97% chances that fall in category 1 or not. How many of you could not understand this point? Able to understand this point? It will be easier for you to go for rest of it. Others, how at 0.001? 0.001 or 0.0017? So this is what I told you. This is coming from the algorithm. So it looks for different factors. Accordingly, it finds out this critical value. I don't get into the mathematics, but this has been found out by the algorithm of decision tree. Our package contains its own algorithm, which is quite acceptable. Okay, I'll try to relate it with the real business minute. Understand these points. So if you look at these numbers, so look at the numbers first of all. Otherwise, we get into the fascinations of business too much. So understand it by this. Exactly, don't have any business connect. This is medical science data. So results also make you help something. So if you look at this data, 7%. What probability 97%? Have you learned about conditional probability? Learned about the conditional probability. Probability, actually, we all learned. If we are from mathematics background, I mean to say, if in our 9th and 10th standard, 11th standard, we have taken mathematics. Conditional probability is a very important module in the probability. Yes, Nagesh. So basically, probability is calculated when something is already assumed. Thing is already done. On the basis of that, you are calculating something. So 97% is not on the whole data. It is not on the entire data. This 97% is calculated only on the 48% of the training data. It is the probability when the AC values are more than 0.0017. So it is conditional probability based on this condition of AC being more than 0.0017. Understand this point? So probability is a probability based on this condition. Now read the rest of the values very quickly. Pick up one more branch we'll pick up, and then we'll get into the example. So rest of the 52% of the data. So we terminated the node here. Reason is we were getting very explicit result. We were pretty confident here with result. If we have 97% of the data belonging to category 1, we go further and create the tree again. Now this data which has 52% of the records. In data, if you look at 60% of the data belongs to category 1. Around of the data belongs to category 1, 26% of the data belongs to category 2, and 15% of the data belongs to category 1. Sorry. But that is not that that's it. That is not very decisive. Around 6% you have falling in category 2. Around 15% you have falling in category 3. So you can't say that with a lot of confidence that this type of data belongs to category 1. No, it has the tendency. This has more proclivity towards category 1. It's and because that you see here, we have actually categorized it in category 1, but it is very light in color. Where if you see dominating this one, dark in color. It is very light because of this. You can't go for any decision. The numbers are not very decisive. Not very decisive. It will go for further creation. Will be created. Yes. So check for the value of LB. If LB is less than 136, you have two conditions here: more than 0.0017 and less than 36. Now this data is this data. The colors are here. It belongs to is one only. It is a dark color here because 21% of the belongs to category 1 here. Data belongs to category 2 and 20% still belongs to category 3. Out of again, decisive statement, you can't go for a decisive statement. Again, it will be missing into 2. Base FM. FM is less than 2. FM is more than 2. If it is less than 2, it's the last one. And here, 29% of the data, and in that, 3% of the data belongs to category 1. We have to stop here. If you go into this, it might again create the problem of overfitting. So to get rid of the problem of overfitting, we have to stop here. We should not be getting same data. It should be realized. So 73% we are getting. We are kind of okay with this. There is which contains 1% of the data, because points will also be very lesser, and you will be creating the model specific to that data. You need to be generalized. If you will see, you have no observation. You have 1% of the data belonging to category 3. One word is there which belongs to category 3. Then go for rest of the analysis as well. So if you want to go for this kind of granularity, which was required in the analysis which I did. But any question in this, whatever we have discussed, so that I can quickly describe you the project I did and I can relate the things. On that, be done by the only by package only, but you again need to calculate the percentage, because that only we use the test data. So we have to look for the misclassification error. And you need to look at the number of records you are having in one node. So you keep creating the nodes, even if you have only 5 records, 4 records, 8 records. So to create a rule, you should have sufficient number of records as well. Okay. Give you one case here, one issue which I discussed. I actually did using this decision tree. These rules. So one rule. So for each branch, you will see one rule, and that you can trace from the terminal node. It will be this. One be this. One find this. What you are getting? Anything manually, everything will be done by the tool only. So, give you an example of which I did. Uh, we have less time. The validity of the deal and categories. Situation news and it's a problem for us. Each and every business. Acquiring new customers is always an issue. Okay. We were asked to build a model help the people to act accordingly. So that model actually was like this. This uh, I had from the past data. I had the uh, different deals, different opportunities. Basically, we all that, and that data is called opportunity. Uh, in that, we had different opportunities: opportunity one, opportunity two, opportunity three, opportunity four. Okay, the deal size of the deal was there. Where that deal was happening, the location, whether it was in New York or it was in where that was happening, location, the product we were selling over there. What is the package? Okay. Person, the character of the salesperson, band of the salesperson, the type of salesperson, whether that salesperson was hunter or that salesperson was farmer. Okay, so characteristic of that salesperson was also there. The key to which that product was being sold. Say, uh, that product was sold was unity, and what companies were there? Compare based. Okay, so variables were there, and finally we had whether we won the deal, we or the about it. So these things we had: one, loss, about. I created the model, and the model something like this. If the size then 50 million and is new where this deal is being pursued. Okay, so the location is New York, and is suppose company. There are only 10% chances of winning and 90% chances of losing, chances of aborting. Okay. Then we have different other things. So if the location is something else, okay. So we have rules. I showed you one branch. So I did the decision tree model because Model was not only to help salespeople understand what is the probability of winning, because if I'll give that number to him, he might not be impressed. And the objective was not to impress him, but to help the business. The business will not be helped in that way. The himself might come with some probability number by his experience. He'll say there are very less chances of winning this deal. I have in the past this kind of competitor is here, and we are selling this kind of product. We don't have much. Uh, I think this product company has better expertise. The kind of pricing we are going with, that pricing might. So people have different kind of uh, uh, to okay. For that analysis, he can also come up with that number, but that number is something which is not the primary objective. The objective was to find out uh, which are in our favor. The objective was to find out the drivers winning a deal. So here variables. Here, if you look at one variable called we can from different rules which product we are selling here. If probability of winning is only 10%, we can product. Look at those things around which we can play around. We can play the product. What we for a better product? We can offer a better packaging. We can include some more products package. Know these rules. We can person. The person input might not be the best for that particular deal. Okay, so kind of corrective measures we can go for if we are having this tree diagram. Not better. Please let me know if you have any question. Great. This model, we apply that model on the validated data set and it will predict the values. And the classification error as well. Let me quickly how we can find out the classification error. Function predict and use the validation data set. Oh, one. Create the tail. What is Uh, Probabilities are coming for data. For the phone, we are getting 97% probability for falling in category 1, 14%, 1.4% probability in falling category 2, probabilities for category 3. What is here? An issue. Let's see where. I also look into this. We don't have the same length. Split it right. Is it work? It is giving the error for everybody. Uh, uh, just not able to figure out why the two are having different. bone length. Let me send you this code. I will click on this and will send you the information. I'm able to figure it out right now. It happened the first in this code. I don't know why it is happening. So I'm back to you. I'll send across one mail on this to all for you of all the students of this batch. Don't worry. This is the one which is not working somehow. Predict is working pretty well. Okay, I'm checking on this thing. Explaining the logistic regression. I'll come this and I, if I can sort it out right now. Half an hour I have kept for logistic regression. Let's quickly understand that part, and then be coming back to this and see the problem. There's some small things we all saying. So talk about logistic regression. I told you this is again a concept is related to classification technique only. So what did you have in that tab? Please use all participant option. No code. Please select all participant options so that everybody is on the same page. move, otherwise we lose time. We have a very important concept waiting for us. I'll check and we'll let you know for sure. I'm sorry, I could not find out right now with the class if I'll have time. So, what we have seen as far, if you look at the regression equation, in that regression equation we had say sales values and axis we had number of calls, relationship between sales and number of calls. With that house prices case study, we had price variable. Alongside price, we had layer and all. Looking at the relationship between cons variables. The scenario when you have variables. Let this scenario only, we have dichotomous variables. Okay. So in scenario, suppose you have one variable as default and variable. Let me create here. Variable as default and dichotomous values here 0, 1, and all. And the variable you have same score. Okay. Now do the same thing which we did in regression, linear regression. We CIBIL score here, and let's keep the value not default here. For use of CIBIL score, you will see if the score is very less, you will see defaulting. CIBIL score is people are defaulting. So because you see only two values here, 0 or 1. Value of this response variable default. Okay. So again, you are trying to find out the relationship, but find relationship this way might not help you, because if you will find out the relationship, you will not be able to find a single line which can represent all these points. These points being dichotomous. That is the main reason why we are not able to find out the linear relationship. Still, we can do something. What we can do here, instead of finding out this thing, we can go and find out the probability. What we do, we can put this kind of diagram. This is probability. It is score here. C. A curve has the equation something like this: P is equal to the power Z. Sorry, here you have C power C plus e raised to the power C. The next curve is sigmoid curve. MOID. a sigmoid curve. Use sigmoid curve, you get out these probability values. What is all about. So let's take the very high value of credit score. Score value is very high. The numerator will be very high because the E lies between 2 and 3. So it will be very high, and denominator will also be very high. You will not be able to make out anything. To make anything, you need to divide the numerator and denominator by the same factor, e to the power c. So your numerator will become 1, denominator will become like this, e to the c. Value of c is very high. What probability here? If the value is very high, the value will be very low. E raised to the power minus c, this value will be very small. And if that is small value you are having, then what will the value be? So it will be very close to 1. So it is very small. Addition of these two values will be very close to 1. So if value is very small, 1 plus this value will be 1. So probability value will be 10 towards 1. Okay, and the same will happen if the credit score value is small. If it's too small, probably this p will be very close to 0. So probability will lie between 0 and 1. Let's have very quickly. It's a cross multiply here. So e raised to the power c is equal to p plus p into e raised to the power c. Cut the same terms together on the left hand side. To the power c 1 minus p is equal to p. E power c is equal to e divided by 1 minus p. If the log on both the sides, you will c is equal to on base e. Log p divided by 1 minus p would be equal to, so on base e can also be written as natural logarithm ln, and p divided by 1 minus p. What is this? Odd. Or defined as the rate of probability of outcome divided by the probability of unfavorable outcome. So what will be the odds for head? So probability that will be 1 by 2, and probability of unfavorable outcome that will be 1 minus 1 by 2, that will again be 1 by 2. So odds will be 1. Log of odds basically you have found out. The keeping here is equal to c. Let's show you what c is. C is the CIBIL score. So have one variable as CIBIL score. Suppose you have multiple variables, two variables to go with. Instead of c, what you can have here the same function beta naught beta 1, 1. If you have more than two variables, beta 2 x2 dot dot dot, that is equal to log of odd. Equation is called Low equation. LEIT. Equation is called Lotte equation. And you see something very interesting has happened. Can you figure out what has happened here? What we have derived here? What did these things and created this type of structure? If you look at these values, a formula, this becomes very similar to that of linear regression. Dichotomous variables, dichotomous values, we were not able to create a regression. But what we have done, we have actually used a transformation here. Independent variables are remaining the same and they are aggregated in the same fashion. What we are trying to do here, we are trying to find out the relationship between the independent variables odds. Log will become a conscious variable. In mathematics, it is very simple. Some cross multiplication and taking the log on both sides. And even if you are finding it difficult, you can leave it because everything will again be done by the tool. Log on both the sides, and then we are creating this kind of equation. So this equation becomes very similar to that of linear regression equation. This is what I wanted to speak about. As you have the linear regression equation, you can always do anything what you want. Now run the code and see output are getting and how we can outputs. So basic use here is just linear model. In regression, you used LM only. That was linear modeling. You are using generalized linear modeling. This you keep, and then in the same fashion you keep the independent variables. Let's take up this only, which we created here. This only PF. Again, break into two parts: test and validation. Okay. So we train. taking, because we have dichotomous values here, can have uh, your model which you can use the same you use for decision trees as well as for KNN. Let's summary. We are more interested in the summary because we have on linear regression and we understood linear regression in a big way. So let's look at the summary. Start off with this. What's the values? Again, p values have been calculated, z values have been calculated. You can understand that there is some test, some hypothesis being tested here. All right, you are thinking in the right direction because we have already done it. This is again same purpose. Check whether there is a relationship or not. So here we are looking for this kind of equation. This beta naught plus beta 1x1 plus beta 2x2 plus dot 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 is equal to law of odds. So these values are not the direct values for beta naught, beta 1 and beta 2. These are actually the values which you have to on the power of e that give you the value of beta naught, beta 2. Basically, this is e raised to the power this value will beta naught. Okay, if you look at this value, if you keep the value as a power of e exponential, this give you beta 1. Really, chain granularity, which is not required, you can take both the sides LHS and RHS as a power of e. To your question, if you go for e raised to the power beta naught plus 1 x1 plus beta 2 x2, answer you will get as e beta naught into e power beta 1, something like that. So they are not the direct values of beta 1, beta naught and all. And you don't have to use it as such. I'm just telling you for the sake of interpreting of these values. Okay, so here you see all these values to be very significant. So there is a relationship between these all independent variables with the dependent variable. So the relationship exists and logistic regression model is valid. Let's look at the values. Deviance and residual deviance. So deviance and residual deviance are synonymous to your R square value. All about R was actually telling you the proportion of variation, the proportion of deviation explained in the dependent variable with respect to with the of independent variable. That is what R square was telling you. Value of R square, better is your answer. So it is synonymous to that only, but let me tell you the interpretation of it. Null deviance is something when you don't have any independent variable. If you don't have any independent variable, that is null deviance. And if you have independent variable, that is if you have independent variables in your model, then that is called residual deviance. So residual deviance should be less than null deviance to have a good model. Okay, whole criteria. So deviance is more obvious. The deviance more, there is no variable. you are considering these all variables in your model, it's the deviation. So get the reduced deviation, that is called residual deviation. The third part is AIC value. AIC value you use to compare different models. So instead of looking at these two, you can only look at AIC value as well. Different models you will consider, higher the value of AIC, better will be the model. Okay. And you proceeding way, the way you actually went about the other models. Sudesh, not complicated. It involves some mathematics. It involves a lot of mathematics. The mathematics part is much more than what I will explain to you. So let me tell you one more thing here. Uh, the, this thing, the basic algorithm. Yes, see. The algorithm behind linear regression was the minimum at least that square values, the residual square values. You minimize those residual square values and you got the answer. That is why it is called OLS regression, of square regression. Here, the algorithm will change. It's maximum likelihood approach. Should make a note of it. Then logistic regression, the basic algorithm is maximum likelihood approach. Algorithm you use for that. A value, a key information criteria. A key information criteria. We compare different models. Information criteria. Okay. Observe this one? Good. So people are pretty good. People are pretty mature to actually get into the projects. So let me take 2 minutes of you here. We'll have a discussion for project mentoring as well, and I'm the part of. I might be the faculty in that session. I might not be, but you will be helped with how you should be solving a project. Should go about different steps in solving the project. You actually should follow CRISP methodology, cross industry standard for data mining. Typing here CRISP, CRISP methodology. You can check on Wikipedia. DM if you type on Google, it will tell you the methodology. If you get a raw data, from that raw data, how will you reach and how will you implement the model? So whole data mining, how you perform, that is actually described here step by step, and you should always follow those steps. Same thing after doing all these projects. So one project you have to submit, but I suggest you people go for all the projects, attempt for all the projects. That only give you the exposure, because we have done a lot of discussion regarding different business situations. We understood the concepts, but now it's time to apply the learning have had. So I suggest go for all the projects. The best one, okay. After attempting all the projects, my suggestion would be connect with me over the Simply Talk community. Okay, so for any assistance, you can drop any question, any query you have on Simply Talk, and that will be answered. Yeah, going to your question. Okay, so I was talking about after doing the projects. Uh, After projects, you can always mention the projects you have done, and you can talk about your projects in any kind of interview as well. So when you talk about the projects, they will be very specific to that project only, and they want to understand whether you are able to apply concepts or not. Okay. After doing the projects, you should go for Kaggle.com. How many of you have visited Kaggle.com? I mentioned this thing in the past as well. Has visited? In Kaggle.com, you should visit now. You should start solving the case studies over there. To start with, what you should do, you should start with a case called Titanic. That case study, Titanic. At this case study, Titanic. Uh, Try case study. This case study can be solved very easily. You this R part. Uh, this R part package. So decision tree is one of the methodology you can use over there. Titanic is a case study about survival of people on the ship. What all measures you should be taking in future so that lesser mishaps. Okay, so look at Titanic. You should solve Titanic, and then Titanic will give you enough confidence to go for further case studies. You now start looking at the solutions in the Kaggle. You would be able to gauge many things over there. Okay, so what I wanted to tell you. Now coming back to the questions. Using the model, Ankit, you can go for predict function. Predict function is applicable here as well. I also suggest you people to explore more on predict function. A lot of things. Explore more on sample function. So now your exploring phase has started. Nagesh, your question, we can go for a time series the time data. Time series analysis is explained much more in detail in our SAS classes. So if you have gone for classes, over there time series is explained till so I divided the courses in this way. So in SAS classes we discuss ARIMA modeling as well. And I will be discussing today ARIMA modeling in SAS. Yeah. So get to know about that in your classes. Okay. So this is what I wanted to tell you. On the closing notes, let me tell you very frankly, you might not be expecting this statement. You might be expecting something like I've taught everything. I will be saying just opposite to that. Only the start. Whatever we have learned, that definitely help you to fetch a new assignment, to promote, to switch to some other analytics department, something like that. But as analytics it is only a start, because it will be you who will be learning. I have tried my level best to complete your foundations and to take you to some good level. From the scratch, I started from the discussion of median and all. I started off with, and now we are discussing some wonderful techniques, some very advanced techniques. We are discussing supervised and unsupervised learning. So we've built our foundations very well. You can go for different kind of assignments, but you should keep learning. My last point would be, please take this point very seriously. You need to survive, so you can get an analytics job very easily. I'm telling you, if you'll solve all these projects and all, you will get analytics jobs very easily. But to survive in the field of analytics, to be successful analyst, there's something you need to keep in your mind. Keep learning. You keep exploring. You keep learning. There is no end. So we need to learn new things and journey ahead. Thank you so much. So much. You people have awesome and very responsive. Let's stay in touch. Thank you. Thank you. Forget to attempt for the feedback form.